Hey, Kim, we're almost at 7:30. Thank you so very much.
Sure.
That was lovely.
I went by so quickly.
I know. Yeah. Well, we really appreciate you coming yet again and giving us another concert. And for people that may have noticed you putting your hand up to the harp in the midst of what you were playing, you want to show where the levers are that you were pushing.
Sometimes I'll have a lever up that's not supposed to be up, and I'll be acting like a machinist, manning this, kind of like a pilot before I take off for my flight. I have to check that all the controls are in the right spot so that I'll land safely. So I'll be here instead of here. In there. So this is going. So this goes up and this goes down to make it flat.
Cool. Changing keys and getting your accidentals.
Oh, this has been the most unique harp. I could really use a pedal harp, actually.
Well, one of these days. Well, thank you again. And I think it is time to welcome everybody to the June general meeting for the Orange County Astronomers. Welcome, everybody. This is our regularly scheduled program. People every now and then ask me when we're likely to go back to a live meeting. When we do go back to a live meeting, we still want to have a virtual component, but we don't yet know when Chapman is going to let us back using the auditorium. So stay tuned. We will let you know as soon as we know. It'll be posted on the website and probably on the email groups as well. Anyway, without more ado, for those that don't know me, I'm Barbara Toy. I'm the current president of this wonderful organization. And for those that were not able to make it out to ANZA for the first informal star party in May, I'm sorry to tell you, it really didn't happen. It was overcast, it was cold, it was gloomy. You couldn't see anything but clouds. So yeah, nobody really was out there. So you didn't miss much. So the first real star party we will have will be in June. And check where the dark of the moon is and where it is on the calendar. And hopefully we'll see you out at ANZA. And without more ado, I will turn it over to our announcement crew. Take it away, Ceci.
Hey guys, good evening. Welcome to June's meeting. It's now summer almost, right? In a few days, so 6 months of the year. Today's crew is going to be Galileo and Paloma. They're getting so big, I know. So let's share screens. Okay. You can see my screen, yes? Okay, so welcome again to the meeting, and here we are. My name is Paloma, and we would like to welcome all new members. Thank you for joining us in this amazing presentation, and yeah, just thank you for being here. So yes, Star Party, as she says, July 9th, our Madam President said, it's great. The other stuff is still pending. Please check the website for the calendar to see time and method of the meeting. What is happening is June 17th, we're having the astrophysics. Astronomy is still to be determined, and the beginning class is July 1st online. And of course, we have a board meeting on July 17th, and any more stuff will be posted on the website for your enjoyment.
By the way, I think the next ANZA Star Party would be the last Saturday of the month.
Yeah.
It would be June 25th.
Okay.
So hopefully we'll be seeing people out there. Hopefully we will have some stars to look at.
This one right here says market calendar. And I think it says it's blocked by mine, but this is for you. So make sure you're there. Next one.
The Star BQ won't be until the end of July.
Right. So, upcoming events, we'll be going to Owens Valley Radio Observatory with the youth group, if you are interested at all, just please contact Doug Miller and Ceci Caballito.
Yeah, I checked with Mark. Everything's a go. We'll have our usual experience up there. If you have any concerns about camping or what we're going to do, give me a call or email me. But everything's a go. We've got about 35 or 40 people.
Yeah, there'll be actually extra photography there. A lot of them, we're taking some professional photographers that actually have been taking photos of the adventures in Marvel and Netflix, and they're going to go out with us to try to take a space pictures for the overalls. That would be great. And I want you to notice this little picture here, this little girl in blue. That's this little girl in blue. Isn't that how time goes by, right? Okay. Mount Wilson, there is some applications coming up. If you guys want to go ahead and do a retreat, we urge you to apply at the site right there from July 17th to the 30th.
We're volunteers we're inviting new volunteers from school and
Yeah, so outreach people, those of you that have live, that's part of the live events, right? Volunteers to please come over and bring your telescopes and teach our wonderful youth about the beauty of outer space. So these were rehearse this, you know, and then when you get on live, it's like, we all freeze, stage fright. All right, try that one again. Two.
hello, my name is Galileo, and today is going to be a waxing give us. Make sure that you see the nice, beautiful night outside, and goodbye.
Okay. We do have for all members, guys, the reason why we should join, if you know anyone that wants to join, one of the reasons is to get a telescope for $5, $10, $30, or they can actually buy one off of us, and it's for a fundraiser for our club, and also they get to see many telescopes to see what they want to use telescopes, so they can commit prior to committing to buying the real one. That's $1,000. So there that goes. Inventory, adoption agreement. And of course, we do have a wonderful and amazing newsletter that's been going on for years on paper, hardcover. Nowadays, it's an option to, do it only digitally, and there will be full color. So we actually do recommend it because it's actually all color. David Fisher, also, if you have any images that you want to submit, the editor is there to show off and, showcase what you are doing outside the club, even during a pandemic. I saw you guys this part. Electronic, it's there. It's full color. To opt out of getting the hardcover, the paper one, go ahead and if you want to stop getting this one, go ahead and contact Charlie so that he can take you off the list. And it saves trees, it saves us money. It's win-win for all of us. Lastly, those of you that are going to ANSA, it's hot, it's fire season, so please, we ask you to please be considering when you go there, even though you didn't grow the weeds, please get them down. Even if it's off, not your pad, and you're walking by and you see something, leave it better than you arrived. And of course, everything else besides keeping it clean, also the refrigerator, make sure that everything's locked. Just keep a lookout for our club. The next meeting will be July 8th, which is, party time for most of us. We're going to be traveling, but luckily it's online. So wherever you are in the world, take the computer or your phone, and you can still join the meeting. And we'll see you next time. Thank you for your presentation and being such patient and wonderful audiences, even during the stage freezes and cold, So thank you, guys. And now, the next presentation. I know, I'm excited to introduce. Actually, I don't think I introduced, but anyway, Doug, go. But I think that's who. Yeah. Does Barbara introduce them? Or should I introduce them? It's you, right? Barbara?
Here's Doug.
Yeah. He's like, we're going to do it like that. Like, but then wait, I don't think I should do that. Our favorite in-house.
Well, Doug will be doing the What's Up for tonight, and we hope you really enjoy it.
Reza, I'm having trouble getting my my PowerPoint up. Basic.
Sure.
It happens.
Okay,
They try.
wait. Here we go. This is doubly embarrassing.
Perfect.
Yeah, because I essentially have a PhD in this field. And anyway, Cloudy Nights, what's up? The idea is we think of things that we want to do or know about when, like at the last Star Party, there is nothing to see. Cloudy Nights. So tonight's Cloudy Nights is an astronomical adventures issue, a second way of looking at it. And you can see it's cloudy, it's night, and there's a full moon. Well, what I thought we'd have tonight is an interview with an astronomer about what choices they've made in equipment, good and bad, and the reasons and the results. Why? Because I keep joining conversations at astronomy events, at club meetings, and online, and people talk about the cool things they do, but that information doesn't usually go beyond that immediate conversation. Even out at ANZA or at Borrego Springs, it doesn't spread very much. So this effort is an effort to spread good information over a wider area and use the experiences of our members and others to inform us. We'll follow the same question formats every time. How long have you been doing astronomy? Are you a builder or buyer? What type of astronomy do you enjoy the most? What have been key choices in equipment, good and bad, that you've made? And what's the next step you're planning? So we'll use those same questions each time to guide what we're doing. In the interview, pay attention not only to what the person is saying, but what they're showing you, because some of that nonverbal stuff may be important. So our first astronomical adventure is with Tony Long, a friend of mine for quite a while. And he made a video for us, and he's going to tell us in his own words as soon as I can get there. Screen share. They changed the Zoom format tonight on us just before the meetings. So we're a little bit stuck. Okay, so here's Tony Long, and already you've noticed his garage is pretty well equipped. More on that privately if you want to know. So here's Tony.
Hi, my name is Tony Long, and I've been into astronomy for about 2.5 years now. It's something that I wanted to get into for a really long time, astrophotography in particular. But it wasn't until about 2.5 years ago that I went to a local amateur radio swap meet and happened upon the deal of a lifetime. You know, the key part of any astrophotography setup is the mount. And what I found at the swap meet was a Celestron C-Gem mount for $80. The guy had no idea what he had. It was an estate sale. And so I got this mount home. It was missing a bunch of parts. I went on eBay and bought a controller. I fashioned some steel threaded rod for the counterweights, and I bought some just workout plates from Amazon again. I 3D printed some pieces and got this thing running. And within about a month, I had my first astrophotography images, and I was hooked. That was it. I took the setup out to the desert, got my first image of the Orion Nebula, and by the way, that is, if you're not aware, that is the gateway drug for most people in astrophotography is the Orion Nebula. It's just it's fantastic. It's easy to image, and it's a great starter drug. Yeah, nebula. Yeah, that's what got me into it. The pandemic has been a nice opportunity to spend time in my backyard doing more astronomy. You know, shortly after that started, I started to upgrade my equipment. I purchased a proper telescope, you know, and really got things working. The question here is, am I a builder or a buyer? And frankly, it's both. I buy pieces, I build pieces. I have 2 small children, so it's kind of impractical for me to build everything, given the limited time that I've got. But, you know, I try and make choices that are wise. If there are things that I can build in a reasonable amount of time that will improve things, I'll do that. But if not, then I'll go out, you know, usually to the used market first, to see what I can find. So what type of astronomy do I enjoy the most? Astrophotography, for sure. That is really what I'm interested in. I've been interested in photography for a long time and really wanted to do astrophotography. And it was the acquisition of that mount that really allowed me to start doing it. I said the first stuff was just done with my camera and a zoom lens and a little guide scope. It really didn't take long to get me set up. And so the part that I like about astrophotography is the continual learning and process that you can make by improving your equipment, by improving your setup, by tweaking your guiding, by learning new things about image processing. And you know, it's a fantastic hobby to see the quality of your images progress over time, both with the acquisition of knowledge as well as equipment. What have been key choices in equipment, good and bad? So, most things have had sort of a mixed story. That Celestron CGM mount that I got at first worked really well for the first couple years. You know, it's had issues. I went in and tore the whole thing apart to try and improve the guiding. It's really not a great astrophotography mount. It's got a lot of backlash and some other issues. Originally, I'd run that thing with a Raspberry Pi and would connect to it remotely. That Raspberry Pi ended up being just a nightmare to get the drivers working right and to get things working reliably. It worked well for about a year, and then just for whatever reason things fell apart, and I decided to switch to a small Windows PC. There's a lot more software available, and I can just remote desktop in. I have a little LCD screen that I put on here, and this thing works really well. I also made a little dovetail setup so that I can move this between telescope mounts pretty easily. I also have a power supply built into this custom tripod pier that I built, and all those things have worked really well. My first telescope was this William Optics GT71. It's a triplet apochromatic refractor with some pretty good glass, and you know, it's a really nice telescope. I bought it used off of one of the websites. I don't remember which one. And that really improved things dramatically over the zoom lens, principally in getting good focus. As anybody who's tried astrophotography with a zoom lens knows, it's hard to achieve good focus and to keep it in focus. The other thing to talk about here is the guide scope. When I was trying to troubleshoot the issues I was having with the CGM mount, I went into looking at the guide scope. I had bought a really inexpensive guide scope off of Amazon, and it was just very hard to get it in focus, very hard to get sharp pinpoint stars that I could use for guiding. So I upgraded that to a Skywatcher EvoGuide 50 ED. And as the name suggests, it is a 50mm ED doublet apochromatic refractor, and it has a field flattener in there that I bought from Starizona, and it actually on its own is a really good, very wide field astrophotography telescope. It complements the William Optics really nicely because I now have a 420mm focal length and then a 240. So it's a really nice combination. I can use either one for guiding and either one for imaging, just by swapping the cameras. The other really nice thing is filters. If you're going to do astrophotography from within a city, and I'm in a Bortle 9 light pollution zone here in Redondo Beach, you've got to have narrowband filters. I use a little filter drawer here that allows me to slide in one filter at a time. I don't have a filter wheel, that's down the road someday. But you know, the narrowband filters that are available today are really, really good, and they are continually getting less expensive and more plentiful in the different manufacturers that are providing them. I use a few different filters. I have an Optolong L Pro, which is a good general use filter for light pollution. And I also have the L Extreme, also by Optolong. That's a dual narrowband filter, oxygen and hydrogen alpha, and it is fantastic. The signal to noise ratio improvement is just phenomenal. and it's really great for imaging some of those nebula. I recently got a sulfur filter as well, and hope to be doing some tri-band imaging and try and kind of replicate that Hubble palette. Let's see, other things. This mount is a recent addition and a portable mount, which is what I really wanted. But more importantly, for you know, as a replacement for the CGEM, it's way better in terms of guiding. I get consistently less than 1 arc second of guiding error, RMS, on this mount, and it's fantastic. The polar alignment is really good. The adjustments are nice. It's just a fantastic mount. Had really good luck with it. Let's see. So what are my next steps? So my next step is to get this guy running. So this is my latest purchase. This is a Explore Scientific ED127 with FCD 100 glass. So this is a triplet, you know, really good glass, low dispersion glass, 5-inch refractor. So this has got a 950 millimeter focal length, and my goal with this is to be able to start imaging some galaxies. Obviously this is not the right focal length for both galaxies and smaller nebula. So this is my next plan to get this operational. I'm probably going to have to replace the CGEM mount. I did some work trying to get it to function, and it just was giving me terrible guiding. The extra weight and the focal length just combined to make, you know, to really just exceed the capabilities of the CGEM mount that I have for astrophotography. You'll see if you look on the forums, just, you know, few people that have a CGEM mount that are happy with that for imaging purposes. And I think I'll probably get something like a EQ6R Pro, something like that. But yeah, that's where I'm at. I've really enjoyed this hobby a lot. It's been fantastic to be able to have some time after the kids have gone to sleep, go out in the backyard, wheel this thing out of the garage, start some imaging, and work on some other hobbies like ham radio stuff, which is my first hobby, while the imaging is happening, and then spend some time processing on those cloudy nights. And it's, you know, this has been a lot of fun. So thank you for your time, and get into astrophotography. It's a lot of fun.
Pull my audio back on. There's a little bit more, just a little bit more. As you can tell, Tony's a pretty interesting guy, and probably he should have not have imaged Orion that first night because it's taken him on quite a journey. If you would like, if you've got something that you want to share for Cloudy Nights astronomical adventures, let me know. I'm kind of interested in Dobsonian telescope ownership, whether it's a stepping stone or a destination. So having some opinions about that might be interesting to have. So if you want to share, let me know, and we'll put you in an astronomical adventures for Cloudy Nights. That'll do it. Thank you very much.
Thank you, Doc, for a first look at what the workshop presentation can be, and looking forward to seeing your next interview.
Thank you.
Hi, my name is Reza, and I'm the Vice President of the club. I too would like to welcome you to the June 10th, 2022 General Meeting of the OCA Astronomers. Our speaker at this meeting is a historian of technology, specializing in space exploration and aeronautics. He has written 4 books on the history of space exploration and 2 on Cold War history. His most recent book is The History of Hubble Space Telescope Operations, published by NASA. He is an ex-president of the Royal Astronomical Society of Canada, and he's a fellow of the British Interplanetary Society. He is joining in welcoming Dr. Chris James. Chris.
Thank you very much. It's great to be able to speak with you, and of course it would be even better to be there in person. I have had the pleasure of being to Orange County a few times a number of years ago, and even taking part in local activities like the Orange County Swap Meet. And I think I still have a few weird and wonderful purchases from that somewhere or other in the house. And I'm going to start off with a little blurb for my book, which you can see the cover here, but this is a different one because no money need change hands, and I'm not going to make any money out of this. But the book is published by NASA, a branch of the United States government, and it is available in electronic and also physical form, free of charge. And I just put a little note on the chat saying where you can obtain it, either in electronic or physical form. And I think that the folks who did the production on this book did a wonderful job with all the pictures and things that I picked out. And so if you come out of this talk thinking, gee, I'd like to know some more, go and get the book, and hopefully we'll answer most of your questions and then some. So I'm an historian who's interested in space exploration. I've written a few books on that. So that's how I approach this topic. But I'm also an amateur astronomer, and I'm going to talk a little bit about that later in the talk. But just going back, who is the Hubble Space Telescope named after? Well, of course, it's this fellow here, and I'm sure you recognize the Mount Wilson Observatory, where almost 100 years ago, just a few months short of 100 years ago, Hubble made his most famous discovery, which was basically determining that our universe is much bigger than our galaxy. Up to 100 years ago, that was a question. Did the universe go beyond the Milky Way? And he was able to determine that we were just, our whole galaxy is just a tiny speck in the much larger universe. And so the telescope that NASA began building in 1977 and named after him is extending that work. And I'm going to talk a little bit about it as we get into the talk. So a couple of other people I want to mention who played key roles in getting Hubble going. One was a fellow, he was an astronomer at Princeton named Lyman Spitzer, also a keen mountain climber actually, but he wrote kind of the first detailed description of a space telescope right after the war in 1946. And he lobbied for decades until Hubble was built, and he lived long enough to make some observations with Hubble. Of course, Hubble was not the first telescope put into space. There were smaller ones in the 1960s, like the Orbiting Astronomical Observatory and various other smaller telescopes. The woman at the right is called Nancy Grace Roman, and she was the first in-house astronomer at NASA, the first head of astronomy at NASA, and she lobbied for Hubble, and so is known as the mother of the Hubble Space Telescope. And of course, when at the height of her career, there weren't many women astronomers in prominent positions. Fortunately, that's changing. And I might add, the next major space telescope that's slated for launch, of course, after Webb, of course, is going to be named the Nancy Grace Roman Space Telescope. and it's going to be kind of more of a survey telescope. It's going to be different from Hubble and Webb. But a lot of people had roles in getting Hubble off the ground, but these are a couple of the important ones. Now, given that most of you are astronomers, I don't think I need to go into great detail on this slide. We all know why you want to get a telescope above the atmosphere, if only to get rid of the soupy skies and the clouds and the precipitation and everything else. But of course, the other issue is being able to look at various wavelengths. And up here, you can see a couple of different telescopes looking in different wavelengths. Hubble itself, unusually for a space telescope, actually looks in optical wavelengths, but also a little ways into the infrared and a little ways into the ultraviolet. And Hubble was the first of a series of what were called the Great Observatories. Hubble, as you know, was launched in 1990, but there are other telescopes launched at that time. The Compton Gamma Ray Observatory, which was obviously looking for gamma ray emissions from stars. It flew for a while, I think, in the 90s, and Chandra, the X-ray, the Great X-ray Telescope, was launched in 1999 by the shuttle and is still operational. And then over at the right here is Certif, which was an infrared telescope. It just actually a year or two ago just stopped operating, and it is now named after Lyman Spitzer, who I showed you in the previous slide. And it was operating in the infrared. So astronomers have been able to image objects in a whole variety of wavelengths, and of course, also looking at them with radio telescopes and things like that. So here's a look at Hubble, which is the most famous of the great observatories. Hubble, by the way, is about as large as a school bus. That gives you an idea of how big it is. And some of you may have seen Hubble during the shuttle servicing missions. And it's powered by solar panels and does not use thrusters to change positions. It uses gyroscopes and momentum wheels and things like that to change its positions. It is about 350 or 300 miles in an orbit, if you know when to look, you can actually see it pass over. I've only seen Hubble once with my own eyes, and that was when I came down to California once and went out and took a look when it passed over. But it doesn't come as far north as my home up here in Canada. And so it has its main mirror is down here, precisely grounded, as we'll talk about in a minute, 94-inch aperture, and then a secondary mirror up here, and then it has a bunch of instruments down here. There are 4 big instruments, and 4 of them are called axial modules because of their shape and placement, and they're about the size of phone booths. And then just above them, just sitting under the main mirror, you have 3 star trackers and the main camera for Hubble, which is and these have been periodically changed out. So an important part of Hubble is that it was, as I said, designed so that the instruments could be changed out over time. by astronauts visiting from the shuttle. So over its lifetime, and it's now into its 33rd year in orbit, we've had a number of different instruments on board Hubble, and you can see this list here, a number of cameras, and then spectrographs, and then a couple of different instruments like the high-speed photometer and the fine guidance sensors, and so that allows Hubble to do photometry and astronomy. What's the term? Anyway, it's able to explore the stars in many different ways, and you can see at the upper right one of the cameras that flew on Hubble. It's a radial instrument, and then you can see astronauts changing out one of the axial instruments during one of the servicing missions. Hubble has a lot of infrastructure on Earth. So the commands to Hubble and the data from Hubble, first of all, go up from Hubble to a tracking and data relay satellite, which you see in this slide. And these TDRS satellites are also used for the space station and the shuttle when it was flying, and various other spacecraft, including national security vehicles. And these the early generations of TDRS were put up by shuttle, and they were able to replace all those tracking stations that some of us older people would remember from the early space flights. So the control center for Hubble is at the Goddard Space Flight Center in Greenbelt, Maryland, which is in the suburbs of Washington, D.C. And Goddard is not the best known component of NASA, but a lot of important work is done there. A lot of the scientific satellites for NASA are controlled from there. Communication networks are run there. And a lot of the Earth science, including looking at climate change, is done at Goddard. And but it kind of does, in terms of Hubble, Goddard is more of a place where the engineering is done. The science work for Hubble is headquartered about an hour's drive away in Baltimore, Maryland, at Johns Hopkins University, the Space Telescope Science Institute. So you have scientists there who actually do academic work, but they instead of teaching as they might do at a university, they do work with people who use Hubble and just do work related to Hubble. So all the data, once it comes down to Earth from TDRS and then goes through Goddard, it goes to the STSCI, and it gets processed, and then it's either sent out to observers who've got time on Hubble, and eventually it's put into archives where it's available to anybody who would care to see that information. And so actually a lot of the work that's being done with Hubble now is, in fact, the majority is not done by people who say, oh, I want some time to look at this. They can just go into the archive and often they'll find what they're looking for. But of course, there's still a lot of demand for Hubble to look at this and that. And so every year there's a process where they choose who gets time on Hubble. And usually there's about 5 or 6 times as many or applications for 5 or 6 times the amount of available time on Hubble, and that's all run by the Space Telescope Science Institute. Now, the James Webb Telescope is going to be a little different. Now, a lot of the work to build it was done at Goddard, and while I was working on this book, I was always sneak into building 28, I think it was, at Goddard, to see how the James Webb was, how its construction was doing. But the actual control center for Webb is at the Space Telescope Institute. There's some reasons for that, because Webb is not in such a dynamic environment as Hubble is. So they felt that it could be controlled out of that institute. So Hubble was, they hoped it was going to be launched well inside the 80s. At one stage it was supposed to go in 1986, but we all know that that was postponed after the Challenger disaster earlier that year. Of course, that was a terrible thing. We lost 7 lives on that, and the Challenger orbiter. But in terms of Hubble, it was something of a blessing in disguise, because a lot of the equipment for Hubble was still not all that ready to fly in 1986. And those nearly 4 extra years that it got were pretty important in making sure that Hubble was a success. As we know, one thing wasn't caught. There was still a big problem when Hubble was launched. They discovered that its 94-inch main mirror was correctly ground by the finest instruments of the day to the wrong shape. And it's a very complicated story that I discuss in some detail in my book. But basically, there was a testing device that was where some economies were taken that shouldn't have been taken, and corners were bent for a variety of reasons. Some of it is NASA's fault. Some of it was the fault of Perkin-Elmer, the contractor. And so when they discovered this a few weeks after the launch, this was a very dark day for the people who worked for Hubble, because, you know, this is a lot of money, as you can see from that cover of Newsweek. There was a lot of ridicule. There's one of the Naked Gun movies where they make fun of Hubble, and various comedians just had a field day, not to mention the cartoonists, as you can see here. But there was a solution, and actually, you know, within hours, people were thinking, well, what can we do? Well, I'm sure some of you have gone a little north up to the Jet Propulsion Laboratory, and that was one of the places where the happier part of Hubble got going, was because the main camera at the time, the Wide Field Planetary Camera, was made at JPL, and they were already starting work on the second generation of that camera that was to go in on a shuttle servicing mission, the Wide Field Planetary Camera 2, WIFPIC 2. And within a few hours of seeing this spherical aberration in Hubble's mirror, some of the people at JPL started working on redesigning WIFPIC 2 a little bit to incorporate special mirrors that acted like contact lenses that would compensate for the spherical aberration. Now, of course, it wasn't quite that simple. There was a huge amount of work that had to be done. They had to figure out exactly the dimensions of the spherical aberration, which fortunately they were able to do. And then they had to think about, well, what about these other instruments we have on board Hubble? And some of the folks at the Space Telescope Science Institute began to work on a solution to that. And they created an instrument called CoStar, which was in effect a set of these mirrors, similar to the ones that were going in WIFPIC 2, but they would be used to change the light in or compensate for the spherical aberration in the other instruments. They had to sacrifice an instrument for the other ones, but that trade-off was made. And then over time, as newer instruments were put in, they were all adapted to the spherical aberration. So finally, CoStar was removed, and anyway, they had to live with the spherical aberration for nearly for 3 or 4 years until the first shuttle servicing mission went up. So that mission delivered in December 1993. It delivered first of all WIFPIC 2 and CoStar. And also, Hubble needed a lot of other repairs. They changed out the solar panels because the first set wasn't that great, and as they had to do with a lot of these and a lot of these servicing missions over the years, they had to change out the gyroscopes and other parts of Hubble that were failing. And the effort that went into that first servicing mission is just amazing. I give it a whole chapter in my book. And, there was a lot of nervousness because there were some other things going wrong at NASA. They were having a set of problems with the shuttle. You had things like the Mars Observer probe disappearing and the Galileo probe to Jupiter, its antenna didn't deploy and which limited its use. They had a lot of things, and if that servicing mission had failed, it might have been the end of NASA. But anyway, a couple of weeks after that crew returned to Earth, NASA was able to reveal this picture, and so Hubble went from being kind of a symbol of trouble in America and just technological hubris to what it has been ever since. For nearly 30 years now, it's been a symbol of American success. And it's all the sweeter because it's a redemption story. It started out with this horrible problem, and they managed to fix it. And the image on the right here is with WIFPIC 2. Well, that was replaced years ago, and now it takes even better images, and the data from its spectrographs is even better. So that is quite an interesting story. So we have had 5 servicing missions to Hubble. The servicing mission 1 I spoke about, and they split the third one into 2 missions, and I won't get into all the discussion, but it's quite interesting. Each mission was different from each other because Hubble was kind of at a different place in its existence over those years, but some of them were more involved in performing critical repairs, and they actually did a lot of repairs that weren't even planned or designed for Hubble, like changing out the main computer and things like that. It's an amazing story, the work that went into each of these missions. And you can see in the later missions, they changed out the solar panels again. But the shuttle hasn't flown for a number of years now. So it's actually been, I think, 13 years since the last time the shuttle visited Hubble. And fortunately, in that last mission, the changes they made, especially in sort of fragile equipment like the gyroscopes, has been more effective than in the earlier missions. So Hubble, when Hubble was launched, they thought they'd get 15 years out of it. And now we're more than double that. And so that's quite an amazing thing. But every now and then, a little problem crops up, so Hubble has to go offline. And of course, one day it's going to conk out. And but I'll talk about that a little later on. But this part of the story, the servicing missions, is really a fascinating story. Really hard work by astronauts, but also a lot of people on the ground who made their work possible by designing tools and things like that. So we all know about some of the amazing images that Hubble has got, and perhaps the most famous one is the pillars of creation in the Eagle Nebula in M16. That was first done in, I think, 1994, 1995. The picture at the left here is actually one that the same area, but done about 20 years later. And then the image at the right is actually the same area, but this is done in infrared wavelengths. So it gives you an idea of what you get with the different wavelengths. You can see through those pillars and see what's behind. The gas isn't blocking it. But of course, this is a stellar nursery. And one of the things that Hubble has done is allowed us to look at stars from their births to even their gestation to their death and what comes afterwards. I'm just going to talk a little bit about some of the scientific work, and of course I could go on for many, many hours about that. But the main Hubble's main job, I think, what they were hoping for was to find, first of all, how big the universe is, and by doing that, how old the universe is, and it's very difficult to do this because, for example, when you're standing on a hill and you see a truck miles away, you can guess how far away that truck is because you know how big the truck is and perhaps how powerful its headlights are. Astronomers, to figure out the distance of stars and galaxies, have had to use this, these various methods here outlined in this slide. For example, for objects close to the Earth, you start off with parallax, their parallax, and then further out, you're looking for a specific type of star, Cepheid variables. And then as you get farther out, you're looking for a specific type of nova. And part of it is looking at these objects closer in and trying to get a more accurate idea of what their size is, and then you can extrapolate. But anyway, Hubble, and actually some as part of a project that has involved a lot of different observatories in space and on Earth, have determined that the universe is roughly 13.8 billion years old, which also gives you an idea of its size. There's still a lot of questions being asked and some discrepancies. Here's some of its discoveries. Now, while they were doing that work, determining the dimensions and the age of the universe, they discovered, astronomers discovered to their amazement that the universe is expanding. Now, that's what they expected, but they thought the rate of expansion would be slowing down. Instead, they found out that it was accelerating, which was astonishing, but the evidence was so convincing that it was actually quickly accepted. But having done that, this expansion doesn't jive with the amount of matter that we've been able to observe in the universe. So now they talk about dark energy, but that term is basically a placeholder. People don't know what dark energy is. And so this is obviously a big project for astronomers these days. I've talked a little bit about the second point. Another important discovery that Hubble was very much involved in was discovering supermassive black holes. Not garden variety black holes, but supermassive black holes at the centers of galaxies. And of course, we recently saw an image of the supermassive black hole at the center of our own galaxy, not with Hubble, but of course with other instruments. That image couldn't be obtained with Hubble because it's just way beyond the capabilities of Hubble, in case you're wondering. During the time of Hubble, of course, this has been the era when we've discovered exoplanets, planets orbiting around other stars. Those are done by telescopes on Earth because Hubble actually isn't suited for that. But once these stars were discovered, Hubble could be pointed at stars with known planets, and it could make observations of their makeup with its spectroscopes, and so it's done a fair bit of work in that area as well. It's also looked at. It's also been something of an observatory for our own solar system, keeping tracks of atmospheric changes in the gas giants and the outer part of our solar system. And very early on, it was a key observatory when we had the comet crash in Jupiter in 1994. It got images of Shoemaker-Levy 9 as it broke apart and headed toward Jupiter, and then got some great images of the impacts. And of course, those of us who were around at the time were able to see it. I can remember looking at, I think I had an 8-inch Newtonian, and I was following it from my back porch, but Hubble was involved in that. And there's all sorts of things. It's made important discoveries about Uranus and Neptune and their moons and things like that. It helped direct New Horizons to Pluto. So there's just all sorts of things to say. But I would say this image here is the most important image that we've gotten from Hubble. It was something that really shook things up. At the time Hubble was launched, some people were saying, why don't we kind of dig or with Hubble's camera, kind of a cosmic borehole. Look at an empty part of the cosmos and take a very long exposure. And I'm not talking about a few seconds. I'm talking about like a whole week of just peering into a piece of empty space. And because time on Hubble is so coveted, that was very controversial. And some of the top astronomers of the day said, that's a bloody waste of time. You're not going to see anything. But the director of the Hubble or the Space Telescope Science Institute has the power to decide just personally to use Hubble for various reasons. Now, everyone who's been director just doesn't get up in the morning and say, gee, I'd like to look at this or look at that. It's usually they hear from people in the astronomical community and there's discussion, and then they use their discretionary time, as it's called, to look at things that may not have gotten time on Hubble through the usual time allocation processes. So Bob Williams was the second director of the Institute, and he decided, let's look at an empty part of the universe. In this case, it was an empty patch in Ursa Major, near the Big Dipper. And it just, late in 1994, I think it was, and it was put out in 1995. And it just looked in there for a solid week. And this is what they found. There was hundreds, if not thousands, of objects in this image. And most everything you're looking at here is a galaxy. So it showed that there was a lot of things out there, even in parts of the universe thought to be empty, at least as we see it from Earth. You do see a couple of stars here. You might be wondering about the bat wing shape of this image, and that was because the WIFPIC 2 had 4 CCD chips, and one was smaller than the others, and that was because of a tight budget. Now for a time, these bat wing images were kind of a trademark of Hubble, but WIFPIC 2 has been replaced, so we don't see these anymore. And so this image was created a sensation amongst astronomers, and also this also came out around the time that a lot of us were finally getting personal computers that were powerful enough to handle images. So one of the very first images I ever downloaded onto my brand new shiny Mac in 1995 was this one. So since that time, Hubble has been used to take lots of images, even deeper into the past and closer to the Big Bang. And this one looks farther than even that last one I showed you. And you see these weird loops here. Well, these are actually distant galaxies, and their light has been bent by the gravity of a galaxy closer in. So this is proving Einstein's talk of gigantic objects and gravity, or galaxies acting as gravitational lenses. So this is one of our deepest glimpses away from the Earth. And so this gives you an idea of how far out and how far back we can look. You can see this has progressed from what we can see from, say, Mount Wilson or Mount Palomar, and then the first deep field takes us here, and then the various deep fields over the years. And by the way, they've used different instruments on Hubble to do those, but also they've used instruments on other space telescopes, and even the odd earthbound instrument to help with some of these more recent deep fields. But of course, to look even further back, just 200 million years away from the Big Bang, you want the James Webb Space Telescope. So, and I'm going to talk about that in a minute, but I'm going to talk a little bit about the time that Hubble was used by amateur astronomers. The first director of the Space Telescope Science Institute was a guy named Riccardo Giacconi, who actually won, he was an X-ray astronomer and won the Nobel for his work as an X-ray astronomer. So, and at first he wasn't that wild about Hubble, but he was known to be kind of a good person in your corner in some of the infighting that goes on in big projects like this. So he was made the director of the first director of the institute. He passed away about 3 or 4 years ago, but I think in recent years, I think he lived in either in or near Orange County. So, but he was an amazing character, but he believed, you know, the taxpayers have put a lot of money into Hubble, and so they should get as much bang for their buck as possible. So he proposed, why don't we let a few amateurs have a go at Hubble? And so that's what happened is in the early years of Hubble, some time was given to amateur astronomers. And at first, they got a lot of proposals, but they went through a couple of rounds. And of course, a lot of this was going on in the era when Hubble had spherical aberration. Now, Hubble was still better than anything on Earth, even with a spherical aberration, but it meant that at least one of the selected amateur proposals never happened because of that. But another thing about Hubble is when you are applying for time on Hubble, there's a great deal of bureaucracy. And I talk about that. And I think that kind of daunted, even though the amateurs didn't have as much bureaucracy as the professionals, it was still daunting. So over time, fewer applied. But I do have a couple of pages in my book that talk about that. And I actually wrote up a bit more of a detailed thing about this program in the Journal of the Royal Astronomical Society of Canada. But it was an interesting little program. All of the amateurs who used it were really delighted. Most of them said it was a life-changing experience. I mentioned one of the proposals was chosen, but was never carried out. But the interesting thing about that was that even though her proposal was never carried out, the woman who won it was so inspired, and she was like an accountant, in Seattle. She went and got her PhD in astronomy and became an astronomy instructor at the University of Washington. So it's an interesting little story. There have been a couple of situations since then where there's been citizen science efforts using Hubble data. There's one that I'm familiar with called, which was took a huge set of images of the Andromeda galaxy, and they needed some help from people to pick out the various types of objects that were being seen in the photos. And so they got citizen scientists to help out with that. Getting back to James Webb, it operates in the ultraviolet, in the infrared, which means that that it can look farther out and farther back than Hubble can. And of course, it's a much bigger telescope. And this slide gives you a comparison between Hubble and James Webb. You see The odd shape of the Webb telescope, of course, is because it includes a sun shield about as big as a tennis court, because infrared telescopes have to operate at very low temperatures. Webb is much bigger and of course operates at much lower temperatures than previous infrared telescopes. So, and I think most of you are aware of the fact that it was launched on Christmas Day. Europe is a partner in the James Webb telescope, as it was in Hubble, by the way. And one of their contributions was to launch it on one of their Ariane rockets. And James Webb is also of interest to us Canadians because unlike Hubble, we are a full partner in James Webb. So we in Canada contributed the fine guidance sensors and one of the instruments for Webb. So we're involved in that too. So one of the big hopes that that astronomers have is for Webb and Hubble to work in tandem over the next couple of years to make observations in their different wavelengths of similar objects. They hope to get 2 years out of that, you know, and then hopefully even more with Hubble. But I'm sort of getting towards the end of my talk now, and some people are curious. Well, what's the end of the story of Hubble? We're into its 33rd year now, it's in an orbit where it will stay up until the 2030s sometime, depending on solar activity, of course. Now, the last Hubble servicing mission has attached a fixture to Hubble, and the plan is for some robot spacecraft to be launched to Hubble to hook up to that fixture and either kick it into a higher orbit from whence it would not come down for a long time, or to bring it down into the probably into the South Pacific somewhere. It is possible that Hubble could land on a populated area, including yours, although it's highly unlikely because, of course, the odds are that 70% of the Earth's surface is water. So, but anyway, that is the plan. Now, some people have said, "Well, gee, can't we bring it back and bring back Hubble and put it on display?" And this slide is kind of an answer to that. I showed all those instruments that were taken up and then replaced, and they've all been brought back to Earth. Now, some of them were actually dismantled and their parts used for the instruments that are up there now, but a couple are on display at the Smithsonian in Washington, and there's some others in different places. Like there was a European instrument that I think you can see in Germany somewhere. And so these are a couple of the instruments that were on board Hubble that you can see in the Smithsonian at the National Air and Space Museum. Maybe not right now, because as you know, they're refurbishing that museum, but they were on display for a number of years. This thing at the left here is actually this CoStar instrument I told you about, which was used to restore the site. And these little arms reached out into the light path of Hubble, and on the other side, or actually you can see here a couple of these mirrors, not much bigger than the mirrors that dentists stick in your mouth. And this here is WIFPIC 2, that camera I was talking about. Now you're thinking, what are all those holes there? It looks like it was in Al Capone's basement or something like that. Or that is the exterior shield of that instrument, and those holes are where it was struck by micrometeoroids or orbital debris. Now that's not what the marks that were made. They actually sort of dug around them and took them out so that they could examine them closely. So it didn't look like that, but everywhere you see one of those things, that's where it was hit by something, usually something smaller than a grain of sand. And one of the test articles for Hubble has been kind of fixed up to look like Hubble. So when you visit that museum in Washington, you get a sense of what Hubble looks like, because that's on display there too. By the way, the famous mirror that was ground to the wrong shape, they actually made a backup mirror for it, which is ground to the right shape, and you can see it at the Smithsonian too. But anyway, I'm not sure how long Hubble is going to keep operating, but there's still a lot of the story of Hubble to be told yet. And even after Hubble stops operating, there is a lot of data that is in the astronomical archives that nobody has looked at yet, because they actually gathered a lot of data in what they call treasury programs, so that astronomers will have things to work on even after Hubble stops flying, because some of the wavelengths it operates on, especially the ultraviolet ones, there's going to be no other instrument up there that can observe in those wavelengths for some time. So I'll leave it there, and if there's time for questions, I'd be happy to answer them.
Thank you very much, Chris. That was a great presentation and insight to the Hubble Space Telescope and its history. So now let me remind everybody that the floor is open for questions. Please go ahead and use the Q&A button on your screen to ask any questions you might have. So while people are typing their questions, let me check if any of the panelists have any questions. Okay.
I guess I answered everything.
So one thing that you actually sent that in chat, and maybe you want to do that again for the members who joined. Your book is available free of charge on NASA's website, an electronic version, and you could also order a free hard copy. Can you tell us?
Yes. And I put the, I mean, you can send them a card or a letter, but you can just send them an email at the NASA Info Center at NASA headquarters, and they'll send out books at least till they run out of them. So it's a very nice book, and it's very well illustrated, and they did, like I said, they did a great production job on it, and it has a lot of information about the story of Hubble, and some of the science there.
Great, thanks.
30 years from the launch up to COVID.
Could I
Thank
ask a
you.
question?
Yes.
Sure, go ahead, Barbara.
You showed some of the pictures that people are familiar with from Hubble. Do you have any favorites of your own that maybe are not the ones that the public is that aware of?
Oh gosh, that's a very good question. There's just there was the famous smiley face picture, and unfortunately I don't have it close. It would take me a couple of minutes to find it, but it was I think it was a picture of a galaxy, but there was some gravitational lensing thing which had a smile. It made it look like a happy face, and actually when I first was hired to write the book, I was in a funny position because people instantly concluded that I was an expert on Hubble. And of course, I sort of had to spend some time working on it, but and I had to give a couple of presentations early on, and I would always end them with that photo. So that's a good one. But there's lots of great ones. But I think that first deep field one, I mean, that is a really there's a really great story behind that one, and I think it's very historic. You know, not only from the viewpoint of Hubble and science, but also in the history of the internet. And I talk about, I have a good chunk of one chapter talking about Hubble and the internet, because I kind of look at, you know, we can talk about, you know, how Apollo was a big television spectacular. I think Hubble was the first internet spectacular.
Great, thank you. And can you tell us a little more about the camera qualities on Hubble? How many megapixels are they, and how do they compare to today's technology?
Let's see. I'd have to go digging around for the numbers. Actually, sometimes I look at that book and I say, gee, did I write all that stuff? I don't have the figures for that, but the most recent cameras that went up in 2009 are like the advanced camera for surveys and WFC3, the wide field camera 3, are actually quite powerful, and you know, compare to you know, what is available on newer telescopes, and they involve some advances in CCD technology, but yeah, obviously things are marching on, and the cameras on board Webb are much more powerful than on Hubble. And one comment about Hubble and its cameras is, because it was the idea of Hubble was kind of to look in, you know, at great distances. These cameras don't have wide fields of view. So, for example, it's not, you know, it can't really be used for surveys, and this is an area where, you know, we've got a lot bigger chips and things like that, and that's what we're going to be seeing with the Nancy Roman Space Telescope. It's going to be a survey telescope. You know, there's a slide I saw on my travels somewhere. You know, this is the dimensions of an image from the Roman telescope, and this is what you get from Hubble. You know, so that's going to be a big change when that telescope gets going, and I think it's still a few years away from launch. I haven't paid that close attention to it, you know, because I've been paying more attention to Webb as well as Hubble. So.
Thank you. And well, nowadays we have many space telescopes of many different types and kinds, the survey ones that you just mentioned, and also the James Webb. But do we have any real Hubble replacements in the programs for the future? Because it's optical wavelengths, and then, you know, it's narrow field, as you said. Anything that closely matches in terms of viewing Hubble's specifications?
Well, there are all sorts of ideas out there. You know, and for example, we just had a couple of months ago, there was a decadal survey released for space astronomy, and they had proposed something. I can't remember what it is right now. Actually, in a sense, I haven't seen too much in terms of proposals for telescopes in optical wavelengths, and I think one reason for that is because of the rise of adaptive optics. You know, because telescopes on Earth are actually getting better at getting images in optical wavelengths. And I mean, I'm sure some of the people sitting in on this talk can and are taking amazing pictures. Well, the speaker before me, you know, after the gateway drug of the Orion Nebula, you know, in my local astronomy club here in Victoria, the Victoria Center of the Royal Astronomical Society, I have some pals who are just taking amazing pictures, and I could probably take them around and show them to a lot of people and say these are taken by Hubble, and they'd be none the wiser. And I'm sure some of you folks are doing that, could do that too if you chose.
Great, thank you. And now, one of the reasons that Hubble was such a successful project, and also its impact, was that it was serviceable, right? We could upgrade, we could, you know, fix it. Now, given that James Webb is not serviceable, do you expect it to have as great impact as Hubble Space Telescope?
Well, we're going to find out starting on July 12th when the first pictures from Webb are supposed to come out. I actually wondered that for a long time, because, you know, you don't you know, see that many ultraviolet images kicking around. But that was one of the reasons why I put up that slide of M16 with the optical wavelengths and the ultraviolet, that they can get some neat images too, you know. And I mean, when I was working on this book, I would talk to people who were also working on Webb, and I said, oh, well, is Webb going to be that exciting to lay people, you know, wanting to see neat pictures? And they tell me that they think it will. So we're going to find out.
Okay, great. I believe I have covered all the questions from the audience. Let me do a last call if anybody from the panel or the audience have any questions. Well, I guess, Chris, do you have any final remarks or points before we go into closing the meeting?
Well, I'll just say one thing. I haven't taken any great pictures because I'm too busy writing history to take astro photos. So that's my contribution. Thank you very much.
Great. Again, thank you very much for such a great talk and joining us tonight. I hope we could have you back in the future with more. So let me thank everybody for, yes, in person, yes. Let me thank everybody for joining us and remind you that you could check the calendar on our website for all our upcoming events at ocastronomers.org. So wish you all great times ahead, and best of luck to everybody.